So 1 mole of any substance is equivalent to relative atomic mass if it's an element, or relative molecular mass if it's a compound. Okay? And we said that there was a scientist, Avogadro, he said that 1 mole of any substance contains minimum number of particles, that is 6.02 into 10 raised to power 23 particles, right? These particles could be molecules, these could be ions, or these could be atoms. Okay? Right? We did this and we just calculate the number of ions, number of moles, right? In the last class. Now, for the gases, right? It is said that at room temperature and pressure, 1 mole of any gas, right? If it's 1 mole of hydrogen, 1 mole of oxygen, carbon dioxide, okay? It is said to be that 1 mole of any gas occupies a volume that is 24 decimeter cube, right? That is also known as molar gas volume, but we do not have to use that word. So 1 mole of any gas at room temperature and pressure, right, 25 degrees Celsius temperature and atmosphere pressure, contains this much volume. Okay? Like we say that 1 mole of any substance contains this much particles. So 1 mole of any gas at room temperature and pressure occupies this much volume, that is 24 decimeter cube. Okay? So according to that, bachu, we have to develop third formula of moles, that is, like you can say that mole is equals to, for gases, volume in decimeter cube upon 24 decimeter cube. Therefore, we say that 1 mole of any gas will occupy 24 decimeter cube. Okay? Right, girls? Then we just have to say that right, we're just taking volume in decimeter cube. We can convert this into centimeter cube, right? So we can just do the conversion, or you can say volume in centimeter cube upon 24,000 centimeter cube. See? So see, girls, 1 decimeter cube contains how many centimeter cube? Is 1,000 centimeter cube. Okay? So make sure that whatever volumes you are getting, you need to convert this into centimeter cube. Okay? So you know that decimeter cube is bigger than centimeter cube, right? Suppose we have got 12 centimeter cube, right? So to convert smaller unit into bigger unit, what you have to do? You have to divide it by 1,000. Okay? Right, girls?
Okay, Miss.
Amreen, Ania, and Aliza, are you getting this, Bachu?
Yes, Miss.
Okay. Achha, I will just solve the simple questions first. Then we will come to the, molar bridge. Okay. So before we move to the next one, I will just revise 3 formula that we have discussed. Number of particles, that how to calculate it. I will not write on that formula. You do not need to do it exactly. So what you have to do, that mole is equals to mass in grams, or mass in tons, mass in kilograms upon AR or MR. AR if it's an element, MR if it's a compound. You will calculate moles, right? Another formula for volume of gas at RTP is equals to, that moles is equals to volume in decimeter cube upon 24 decimeter cube. We could also say that volume in centimeter cube upon 24,000 centimeter cube, right? But just learn the conversion. 1 decimeter cube is equals to 1,000 centimeter cube. Okay. If you want to note down, but note it down so we could just solve some simple questions first. Okay.
Okay, Miss.
All right, girls. See, This is what we have already discussed. कि 1 mole of any gas occupies 24 decimeter cube at room temperature and pressure, right? So, like if you're saying that 1 mole of hydrogen gas hai, so it's going to have equivalent to its MR, that's 2 grams, and volume will be occupied as 24 decimeter cube, right? So if it's 1 mole of oxygen, 24 decimeter cube, 1 mole of carbon dioxide, 24 decimeter cube, right? So 1 mole of any gas has 24 decimeter cube volume, right? And we just have, deduced this formula as well. Now let's do this question, right? Calculate the number of moles of oxygen when 12 decimeter cube of oxygen reacts with nitrogen at room temperature and pressure. Okay. So what we have to do, we just have to calculate what number of moles. We have to find out from the question what you are going to do. When what is given to us, but your volume, right? Volume of oxygen. Okay. So we know that moles at RTP can be calculated by the formula volume in decimeter cube upon 24 decimeter cube. Right, girls? So, but your volume in decimeter cube is given, that is 12 divided by 24 decimeter cube. So, we'll get 0.5. Okay? Do let me know, girls. Are you getting it? Aliza, Anya, and Ambreen?
Yes.
Okay. Suppose, but if they would have asked that what will be the mass of oxygen, so what should we have done? Suppose if they would have asked, calculate the, what mass of oxygen will be required. So once we got the moles, so we know that another formula of moles is that moles is equals to mass in grams upon mr. Okay? Suppose, if they would have asked us that what will be the mass, so what you will do, you will multiply moles by mr of oxygen. Okay? But make sure that your oxygen is diatomic, right? So you will take mr of oxygen as 32. So yeah. So if you multiply like number of moles that are 0.5 by mr, that is 32. So what you will get will be mass. Okay? So that's going to be 16 grams. Right, Bachu? This is what even we have said. कि भाई 1 mole of oxygen is equal to relative molecular mass, that's 32. So half mole का mass क्या होगा? 16 grams. है ना? We are even proving it. Right, girls? Should we move to the next question? I will
Yes,
share this
miss.
presentation with you because you can have all the resources with yourself. Okay. अच्छा अब देखो this question. How will you do that? What volume of methane will occupy when 2 moles? What is given to us? 2 moles. What do you have to calculate? Volume. ठीक है? Is combusted at room temperature and pressure. अच्छा बच्चों, see, we will also be doing another formula for concentration in which we can find out the volume. So yeah, we'll not do it today. We'll do some other time, or just let's see. अच्छा अब देखो, what you have to do is we have to calculate volume and number of moles are given at room temperature and pressure. So it should come in our mind that moles is equals to volume in decimeter cube upon 24 decimeter cube, right? This is the formula that you have to use. Okay. Now see, but we have to calculate the volume. The number of moles are given. So what will be the volume of 2 moles? We'll just multiply 2 by 24. Okay. So that will be 48 decimeter cube. Right, girls? Is that clear?
Yes, miss.
Okay. Anya, are you getting it?
Yes.
Okay. All right, okay. So let's move to the next. Let's do this together, okay? Or you could also try side by side. What volume at room temperature and pressure would the following gases occupy? So yeah. So we have to calculate the volume of 0.5 moles of carbon dioxide. Okay? I will also, suggest you people to write on the formula first, unless we're just getting it, we are just learning it properly. So volume in decimeter cube, even these are going to be fruitful for your A levels chemistry, right? Volume in decimeter cube upon 24 decimeter cube. So moles are given, we have to calculate volume. So what you will do, you will simply multiply number of moles that are 0.2 by 24 decimeter cube. So हमारे पास volume आ जाता है, right? So 0.2 into
4.8.
Yeah. So that's going to be 4.8 decimeter cube, right? Great. So this one, 3 moles of nitrogen gas. Can you try what you will do, but the B may 3 multiplied by moles are 3, so
24,
multiply by 24. Haan, shabash.
72.
72 shabash. So that's going to be 72 decimeter cube, right? So sometimes they do ask us to write on volume in centimeter cube, right? So to convert bigger into smaller, what you will do? You'll multiply by 1,000. Okay? So it will be 72,000 centimeter cube, right? Acha, 0.1 moles of chlorine gas. Again, we have to find out volume. So 0.1 multiplied by
2.4.
very good. 2.4 decimeter cube. As a here, they haven't given us the moles, they have given us mass, right? So what should we do? I need your suggestion, girls. What should we do first?
We use the formula for moles equals
Very
grams
good.
and
Very nice. We will first use the formula of moles, that mass in grams upon mR, to calculate moles. Very nice. And then we will multiply by 24 decimeter cube, right? Shabash. So moles is equals to, I'll write on the formula, that is mass in grams upon mR. So mass in gram is 4 divided by mR of oxygen is diatomic, that's 32. तो हमारे पास क्या आ जाएगा 4 divided by 32.
0.125.
Sure.
Is the answer
0.125.
is 3 decimeter cube?
Very nice.
I mean
0.125 into
3.
24 decimeter cube. Shabash. So we'll get 3 decimeter cube, right?
3.
Great. 4 grams of sulfur dioxide. Can you try, girls? I'm writing AR of sulfur is 32. Oxygen is 32. Find out MR of sulfur dioxide, okay?
So then the answer is the same.
Excellent. No,
Oh,
but
never mind.
no, Anya,
Yeah.
sulfur
Got it.
dioxide. Okay, great. So 4 divided by 64 is I think.
So we add 32 plus 32? Or?
Yeah. Sulfur is 32 plus 32. So that will be 64, right? So
But aren't there 2 oxygens?
yeah. Sulfur dioxide are 2. Once oxygen is 60, यहाँ पे I have written. Correct, huh? One oxygen is 60. Sorry. Okay. Yeah. So the MR of sulfur dioxide is 64 actually. Okay. So
is it 1.5?
1.5.
Is the answer 1.5?
Yes,
yeah.
It's 1.5 now, yeah. Very nice. That's going to be 1.5 decimeter. Okay. Is it clear to all of you, Baju?
Yes.
Okay. Acha, before we move to the next one, let's solve some questions from past paper. Okay. Then, if needed, we could just start the another formula, right? Give me a second. Okay, Bachcho. One thing I need to tell you, that is a stoichiometry, right? What is it? Let me explain you, then you'll do that question. Dekho, whenever, like, I'm just writing an equation, okay? So let's see how you're going to, read it out. Like, if I'm writing sodium reacting with oxygen to give us sodium oxide, right? That is, we write on the correct formula. Then we just balance the equation, okay? right? Acha, how can we say that this equation? Can we say that 4 mole of sodium, so yeah, react with 1 mole of oxygen, so yeah, to give us how many moles of sodium oxide? 2 moles of sodium oxide. Do let me know, girls. Do you agree with it? Anya, Aliza, Amreen.
Can you repeat?
Sure. देखो, we were supposed to do that this is a coefficient, है ना? So what is coefficient? Actually, that represents the number of moles. We can say that 4 mole of sodium reacts with 1 mole of oxygen to give us 2 moles of sodium oxide. ठीक है?
Yeah.
Similarly, बेटे, if I'm writing के चलो, magnesium plus hydrochloric acid is going to give us magnesium chloride and hydrogen gas. ठीक है? Right? So how are you going to say how many moles of magnesium are reacting? I need your input.
1.
1,
1 mole of magnesium is reacting with how many moles of HCl, बच्चों?
2,
Very
2.
good. How many moles of magnesium chloride are being formed?
1.
Very good. How many moles of hydrogen is being formed?
1.
1.
Very nice. ठीक है? So why did I tell you this? That is said to be stoichiometry. ठीक है? Now, if I just say that what is the ratio of magnesium and magnesium chloride? So it is 1 is to
1.
excellent. If I'm asking that what is the ratio of hydrochloric acid and hydrogen? It is
2:1.
2 is to 1. Very nice. Okay. So, beti, by looking at the ratio from the equation, you can find out the moles. Okay. So this is the mole bridge. You are going to find out the moles of one species and you will apply the ratio stoichiometry to calculate the moles of required quantity. Okay, I'll just give you a simple example over here. Again, I will try to explain you if you people have not got it. Okay, suppose I'm asking aluminium plus oxygen is going to give us aluminium oxide Al2O3. So yeah. Now see here, when I balance it, so I have to say. So you know that 4 moles of oxygen, aluminium reacts with 3 moles of oxygen to give us 2 moles of aluminium oxide. ये बात clear है for all of you? Ania, Aliza, Amreen, Tuba?
Yes.
Tuba, just whatever is written over here, that is going to be the moles, okay? 4 mole of aluminium, 3 moles of oxygen giving 2 moles of aluminium oxide, okay? अच्छा अब देखो बच्चों, my question is that what mass of aluminium oxide will be formed when 2.5 moles of aluminium burns in excess of oxygen. I will let you know what is meant by excess and limiting reagent or cheese aa jayegi isme, theek hai? But let's understand the simple questions, theek hai? Now what you have to find out, you have to find out the mass of aluminum oxide. There is going to be direct method as well. I'll let you know that method as well, theek hai? But by using the molar bridge, how are you going to find out the mass of aluminum oxide? The very first thing that you have to do is take the moles, okay? Or what do you say that? Calculate moles. Suppose moles नहीं given यहाँ पर, mass given था, ठीक है? 5 grams of aluminum. So what you are going to do is to calculate moles, ठीक है? For every moles questions, this is what you have to do. Even they must have given us directly moles as well, ठीक है? But I'm just asking that if mass is given, so what you will do, you'll calculate moles of given species. Like here, a mass of aluminium is given, so you're just going to calculate moles of aluminium. Okay? After that, you are just going to apply stoichiometry. What is stoichiometry? Is a ratio from the equation. Okay? That is a stoichiometry you will just find apply for aluminium and aluminium oxide. Okay? Because you have to find out the mass of aluminium oxide. So yeah, stoichiometry is a ratio from the equation. Then what you will do, Bachu, will calculate required moles and then find out mass, right? Don't worry, I'll explain to you. Calculate required moles, right? Species moles. Then calculate mass or even volume, whatever is asked. Okay? This is known as molar bridge or mole bridge. This exam gets over, so I'll explain you. Okay. All right, girls. Okay. So this is a molar bridge that you have to follow. Okay. You will calculate moles of given species, right? Articles, should we rejoin so that I just have closed it down. Let's rejoin. I'll write on the question again. Okay. Let's do it together. Rejoin, right?